Dear third prep, Assalamu alaikum wa rahmatullahi wa barakatuh. It's Mr. Ahmed Mahmoud with you today to introduce a new mathematics lesson. Today, inshallah, we have Algebra. It's Unit 1, Lesson 3. The lesson is called Symbolic Notation of a Function and a Polynomial Function. In this lesson, we have two items. The first, we have to learn the symbolic notation or representation of a function and how can we write the function, and we are going to complete the meaning of the function as we studied last time, and we are going to learn what the meaning of the polynomial function, and this is the first type of functions we are going to study. The second type you are going to study in the second term, inshallah, and the rest of the functions rules you are going to study in the second of secondary بإذن. Let's start the lesson. The symbolic notation of a function. Notation means representation or writing a function. For example, if we have a function from x to y, this is the title of the function from x to y. Mathematically, we are going to replace this statement by a symbol like this. Again, function from x to y, we are going to replace this statement by another by symbol like this. F, the symbol of abbreviation of the word function from x to y. X means the domain and y means the codomain. Then this symbol means function from x to y. We replace this symbol in place of the long statement as we typed before. Okay, now we have another statement. Y is a function of x. We can classify this point or this statement by another meaning. Y is the codomain. Function of x, x is the domain. Another meaning for this statement, y is the image of x. Again, y is a function of x or y is the image of x. I will replace this statement by symbol like this. F of x equal y or function of x equal y. Y here is the domain, the codomain, and f of x equal y, x here the domain. Okay, then this symbol read as f is a function from x to y, where x is the domain of the function and y is the codomain or the function. And next, inshallah, we are going to write these symbols. Don't forget, f of x equal y, then y is the f of x. Okay, now we have an example we have studied before. In this example, set x equal 2, 3 and 4 and y equal 8, 27 and 64, and r is a relation from x to y where a or b or a related to b means b equal a power of 3. We already took examples like this one in the last lesson. Okay, just to remind you how can we solve this ones. Okay, and I need to compare the symbols here in this example by the new symbols in the new lesson. Okay, now to solve this one, I need to write r by using this rule, b equal a to the power of 3. Okay, if a equal 2, then 2 power of 3 equals 8. Then r equal 2 and 8, and if a equal 3, then 3 power of 3 equal 27. Then the second element is 3 and 27, and if a equal 4, then 4 power of 3 equal 64. Then the third element here is 4 and 64. Okay, now to represent this one by order pair like this, x and here y, x included 2, 3 and 4, y included 8, 27, and 64. And I'm going to connect 2 and 8, 3 and 27, 4 and 64. Okay, now by looking to the rule b equal a power of 3. Okay, b here is the second coordinate, okay, and a is the first coordinate. Okay, we said before that any order pair represented two projections, the first is x and the second is y. Then in this lesson we are going to replace b with y and a with x to be like this: y equal x power of 3. In place of b equal a power of 3, we are write it y equal x power of 3. Okay, next inshallah we are going to write these symbols y and x, not a and b. Okay, now as I said here, y equal f of x, then I can replace y with f of x to be like this: f of x equal x power of 3. Then when we say f of x, then we mean y. Again, when I say f of x, it means y. And when we write f of x equal, then we are going to write the rule of the function, which is x power of 3. Okay, now here in this example, as we see y here, I can replace it with f of x like this. Okay, then f of x is represent y, the set of y, or the opposite or the codomain of the function. And as we said before, f of x, then the image of 2 is 8. It's written like this: f of 2 equals 8. It means the image of 2, the function of 2 is 8, and the function of 3 is 27, written like this, and the function of 4 equals 64, written like this. This one read f of 2 equal 8, and this one f of 3 equal 27, and this one read as f of 4 equal 64. And don't forget that the number inside the bracket is x, and the opposite number is y. This is a very important remark. Again, the number inside the bracket is x and the number outside is y. Okay, let's solve the next example. Don't forget before we leave this page. Okay, f is a f where x to y means function from x to y, and f of x equal y. This is the new notation of the function. Okay, in the next example, here we have example 1. In this example, if x equal 1, 2, 3, and 4, and y equal 0, 2, 4, 6, 8, and 10. Okay, the first required, okay, here f is a function. When he say function, then it's already a function. As we studied before, the function from x to y means every element from x has one image from y. Okay, this symbol means function from x to y, where x is the domain, y is the codomain. The function f of x equal 2x, or by another meaning y equal 2x. Okay, then the rule y equal 2x or f of x equal 2x, because f of x equal y. Okay, now I need to find f. First, at x, if x equal 1, then f of x or y equal 2 times x equal 2. If x equal 2, then f of x or y equal 2 times 2, 4. If x equal 3, then f of x equal 3 times 2, 6. And here, if x equal 4, then f of x equals 4 times 2, 8. Now I need to write r. F equal set of 1 and 2 bracket 2 and 4, 3 and 6, and finally 4 and 8. This is F. Okay, now I need to represent by an arrow diagram. Okay, here in X we have 1, 2, 3 and 4. Here in Y we have 0, 2. Don't forget that Y equal F of X. 0, 2, 4, 6, 8 and 10. 1 connected with 2, 2 connected with 4, 3 connected with 6, 4 connected with 8, and this is the representation of the arrow diagram. The next one, in example 2, we have if x equal to 4 and 6 and the function x, the function f from x to r. That means the domain here is x, the codomain is r. Again, x, the domain is x, the codomain is r. And this is the rule of the function f of x equal to x plus 3, or by another meaning, y equal 2 times x plus 3. Okay, now find the range of this function. Okay, first at x equal 2, then f of x equal, put 2 here, it will be 2 times 2 plus 3, which is 7. And at x equal 4, then f of x equal 2 times 4 plus 3 equals 11. At x equals 6, then f of x equals 2 times 6 plus 3 equals 15. Then the range equal set of 7, 11 and 15. Okay, the next example. If f is a function on x, where x equals 3, 4, 5 and 6, and f of 3 equals 3. Don't forget, f of 3, that means 3 is x and this one is y. F of 4 equal 5, this one x and this one y. F of 5 equal 6, this one x and the 6 is y. Okay, and here 6 is x, 5 is y. F of 6 equal 5. Okay, represent by an arrow diagram and also by Cartesian diagram and write the set of f. Okay, first the arrow diagram. Here it's a function on x. Okay, in the first set we are going to write 3, 4, 5 and 6, and here 3, 4, 5 and 6. 3, f of 3 equal 3, then 3 connected with 3. F of 4 equal 5, then 4 connect with 5. F of 5 equal 6, then 5 connected with 6. F of 6 equal 5, then 6 connected with 5. Okay, this is the arrow diagram. The Cartesian diagram. Here we have 1, excuse me, 3, 4, 5 and 6. 3, 4, 5 and 6. Here 3 and 3, 4 and 5, 5 and 6, 6 and 5. It will be like this, and I need to write f equal set of order pair 3, 3, 4 and 5, 5 and 6, 6 and 5. The next one. Now we are going to learn the polynomial function. Okay, the polynomial function, this is another meaning of the function. This is the first set we are going, or the first rule we are going to learn. As I said in the introduction, we are going to learn the first type in this term and the second type in the second term, and in the second of secondary we are going to learn the other functions. Okay, now I need to explain what the meaning of polynomial. Polynomial, this is a word, okay, formed from two parts, poly and nomial. Poly means many, nomial means term. Then the word means many terms. Polynomial is many terms. That means it's a formed from many terms on X. Okay. The polynomial has two conditions. The first condition, the rule is term of X. Okay. The rule of the function is a term of X. For example, x power 2 plus 3x plus 5. This is a rule formed from three terms. Or for example, 5x, this is one term. Or x plus 1, this is two terms, and so on. Okay, then the polynomial function is a rule in terms of x. The second condition, the powers of x is natural number. Again, the power of x is a natural number. Okay, the natural number, as we studied before, is 0, 1, 2, 3, 4, 5 and so on. Okay, then the powers must be number of these numbers. Okay, then the powers of x must be 0, 1, 2 and so on. Okay, if the power is fraction, then it is not a polynomial. If the power is negative, then it is not a polynomial. For example, f of x, this is the title of the function, means function of x or y equal. Okay, and this is the rule. Here in this example we have x power 2, this is one term, and negative 2x, this is another term, and negative 2x another term, and the positive 1 is another term, the third term. Here we have x power 2, and here we have x power 1, and here we have no x, that means here x to the power of 0. Then the whole function formed from three terms, each of them the power of x is natural, here x power 2 and here x power 1 and here x power 0, then we can say that this one is a polynomial function. Okay, another example, f of x equal 2x plus 5, here x power 1 and here x to the power of 0. Then the power here and the power here is natural, then this one is a polynomial function. Another example, f of x equal 3, which means x power of negative 3 x power 0. Negative 3x power of 0 also is a polynomial function. Here, this one formed from 3 terms. And here we have 2 terms. And here we have 1 term. It's already terms of x. Then all of them are polynomial functions. Okay, another example. If we have x power 3, it's no problem. Here we have root x. Root x is a fractional power. Root x means x power half. And you are going to study how can we change this one in the second of secondary. Okay, so this one is not a natural power. Okay, then finally this one is not a polynomial function because we have here power doesn't belong to n. Another example. Here we have x power of 2 plus 1 over x. 1 over x means x power negative 1. And x to the power negative 1 is not a natural power. So this one is not a polynomial function. Another example. Here we have x power negative 2. It's not a natural power, then it is not a polynomial function. Finally, we can say that the polynomial function is a rule, is terms of x, and the power of x must be natural power. Okay, then the first 3 examples are polynomial functions, and I explained why they are polynomial functions, and the last 3 terms are not a polynomial function. Okay, let's study the next concept. The degree of the polynomial function. The word degree is not a new word. We studied before the meaning of the degree in the first prep. Means the highest power of x in the function rule. Again, the highest power of x in the function rule. Okay, if we have more than x, then we choose the highest power, and this one will be the degree of the function. For example, here we have x power 2 minus 2x power 1 plus 1x power 0. The highest power here is x power of 2, then this one is from second degree. And the other one, here we have 2x power 1, and here we have 5x power of 0. Then the highest power is x power 1, then this one is first degree. The third one, 3 or 3x power of 0, then this one 0 degree. Another example. Here x power of 3, this is the highest power, it's third degree. The next one, if we have x power of 2 times x plus 1, if I need to expand this bracket, then I'm going to distribute x power of 2 like this. X power of 2 times x equal x power 3, and x power of 2 times 1 equal x power of 2. Finally, the highest power here is x power of 3, then this one of third degree. Okay, if I have x power of 2 times, after expanding this bracket, the biggest x will be x power of 2 because this bracket power 2. X power of 2 times x power of 2 equal x power 4, then this one from the fourth degree. Okay, then what's the meaning of the degree? The degree is the highest power of x. The next one, let's solve some examples about the polynomial function. In this example, write which of the following represent a polynomial function and which is not. Okay, here number 1, 2x minus 5. This is a polynomial function because here we have 2x power 1 and here we have x power of 0. The power here and here is natural. Then this rule is a polynomial function. Okay, another example. Here we have x power 1, but here we have 1 over x. That means this one x power negative 1, then this one is not a polynomial function. Another example. Here we have x power root x, which means x power half. Power half is not natural power, then this one is not a polynomial rule. Number 4, cubic root x means x power 1 over 3. Again, cubic root means x power 1 over 3, then this one is not a polynomial rule. Number 5, here we have x power 1 times x, and here we have 1 over x, which is x power negative 1, then this rule is not a polynomial function. Okay, another example. In this example, f of x equal 5x power of 2 plus 7. Of what degree? This is of the second degree. This is very easy. The second one. Here we have x power 5 times x plus 1 is a polynomial function of what degree? Here we have x power 1. X power 5 times x power 1 equal x power 6, because we add the powers, then this one of the 6th degree. The next one. Here we have x power 2 minus x power 2 minus 3. Okay, now I need to simplify this one. Okay, I will write x power of 2 and I will distribute negative among the bracket to be negative x power of 2, negative, negative, positive 3. X power 2 minus x power 2, 0. It will be 3. Then this one of 0 degree. Why 0 degree? Because we have here x to the power of 0. The next one. X power of 2 minus x plus 3, as we studied before in the function notation. F of 2, that means x equal 2. Then I will replace x here and here with 2. It will be negative 2. Don't forget to put between brackets and the power outside the bracket like this, minus open bracket negative 2 plus 3. This one equal 4 plus 2 plus 3 equal 6 plus 3 equal 9. Okay. The next example. Here we have example 6. F of x equal to x power 2 minus 5x plus 2. This is a polynomial function. Prove that f of 2 equal f of half. F of 2 means the function at x equal 2. And the f of half means the function at x equal half. Okay. First I will find f of 2. I will put in place of x 2. 2 between brackets 2 power of 2 minus 5 between brackets 2 plus 2 equal, this one equal 2 times 4 equals 8 plus 2 equal 10. 10 minus 10 equals 0. And f of half means 2 open brackets half all to the power of 2 minus 5 times half plus 2. It's equal 2 times half power of 2, 2 times quarter equals half plus 2 equal 2.5. 2.5 minus 2.5 equals 0. Therefore, f of 2 equal f of 1 over 2. Both of them equal 0. The next example. If f of x equal to x minus 1, prove that f of 2 minus 3 f of 1 equals 0. First, I will find f of 2 and the f of 1. F of 2 equal 2 times 2 minus 1 equals 3. and the f of 1 equal 2 times 1 minus 1 equals 1. Okay, therefore f of 2 minus 3 f of 1 equal 3 minus 3 between brackets 1. 3 minus 3 equal 3 minus 3 times 1. 3 times 1 equal 3. 3 minus 3 equal 0. Therefore, f of 2 minus 3 f of 1 equal 0. The next example, if the function f from r to r, where f of x equal x power 2, then f of 2 plus f of negative 2. Okay, f of 2 plus f of negative 2, here x, the function rule x power 2. f of 2 means x, 2 power of 2. Plus f of negative 2 means negative 2 all power of 2. It's equal 2 power of 2 4 plus 2 power of 2 4 equals 8. Then the function here equals 8. The next one, if f of x equal ax plus 6, then f of 2 equals what? Here this one is x and this one is f of x or y. Then in place of f of x I will write 2 and a here between brackets. In place of x I will write 2 plus 6. Okay, this is an equation. In this equation it will be 2 plus, excuse me, 2 equal 2a plus 6. Okay, I will switch the equation to be easier. Then 2a plus 6 equals 2. I will send 6 there to be negative 6. Then 2a equals 2 minus 6 equals negative 4. And then I will send 2 there as divided by 2. Then a equals negative 4 divided by 2 equals negative 2. And this is the equal of a. It's negative 2. The next one, f of x equal x power of 2 minus x plus 3. Then it will be 3 power of 2 minus 3 plus 3. It equals 9. The next one, f of x equal x minus 5. Then half f of a equal 3. Then a equal what? Okay, here we have in place of f of a I will write the rule, okay, like this, half, and between brackets I will replace x with a. It will be a minus 5 equal 3. Okay, then a minus 5 equal, I will send the half there to be divided by half. 3 divided by half equal 6. And then I will send minus 5. Then a equal as plus 5. 6 plus 5 equals 11. Then a equals 11. And this is the end of the lesson. I hope it was helpful for you. See you in the next video inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh. Mr. Ahmed Mahmoud was with you.